Um,
Okay.
Hello to everybody online.
Yeah.
Welcome.
Yeah.
Via Zoom, and hello to everyone here in the room. I want to first couple of announcements. I'm going to circulate this sign-up sheet. It is for let's start it over here. We can pass it around. This is a sign-up sheet for refreshments. We've got 3 more months that still need volunteers for refreshments. So if you're so inclined. I also wanted to thank Eric for all his work to put the audio-visual together in the Zoom meeting. If you guys on Zoom can see what's on the desk here, you'll know how much work he's been putting into getting it to work. And last month we got several compliments. So Eric, you're getting the system, yeah, dialed in there. So. Annie, thank you for the use of the room. You see, we're making good use of it. So we want to thank you. Okay, so without much ado, let's go ahead and jump right into our presentation for tonight. And then we've got a couple of announcements to wrap it up after that. So it's my great pleasure to introduce what I think is my new friend from Sacramento, Michal Warzecha. And a little bit about Michal. He's a NASA solar system ambassador, and he's been fascinated with astronomy and space travel since his childhood. Anybody can relate to that?
No.
He has been an amateur astronomer for over 40 years, mostly visual, and he is an aerospace and mechanical engineer and has worked on programs including the 777, Atlas V, Artemis. Are you guys catching on? So some pretty big names here. The Cobra rocket engine. Maybe he'll tell us a little bit more about that. Or maybe we could invite you back just for a presentation on all your aerospace work, right? And he now works in developing zero-emission hydrogen fuel cell trucks and lives in El Dorado Hills with his family. So please join me in welcoming Michal Warzecha.
Thank you, Tim, and thank you for the invite. And thank you for the warm welcome here in Stockton. And I am also part of the Sacramento Valley Astronomical Society. I'm on the board of that, and I'm happy to be working together with this club. And it's great to join up with everybody in the region. And so I will start out by talking about the Solar System Ambassador Program. And we're a nationwide program. Oh, sorry. We are a nationwide program that's run out of JPL. And there's over 1,100 volunteers in the United States. And what we do is public outreach regarding space, STEM topics, etc. We want volunteers from all walks of life. You don't have to be an engineer. You don't have to be a scientist. We have a lot of teachers. For a while, we had a Catholic nun. In my training class for this year, we had a composer who was writing music about the stars. So if you're interested in volunteering, come talk to me. The application process is every September. And it's really fun. You do a lot of talks like this. I've worked with schools, I've worked with observatories and whatnot. So that being said, I'll start out about Hubble. And we all know about the Hubble Space Telescope. We've all heard the name. However, and starting at the end of the 20th century, the Hubble Space Telescope revolutionized astronomy. Our understanding of the universe has dramatically improved with his discoveries. But just as important as Hubble is his namesake, Dr. Edwin Hubble. He lived and worked at the beginning of the 20th century, and he basically rewrote astronomy. So the Hubble Space Telescope is an excellent namesake with Dr. Edwin Hubble. And both the space telescope and the man upended our perception of the universe. So in this presentation, I'll talk a little bit about Hubble, the man. I will talk about how we came to our understanding of cosmology in the 20th century, and then how Edwin Hubble basically upended our views of cosmology in the early 20th century. So Edwin Hubble was born in Missouri in 1889, and he loved science fiction as a schoolboy. He spent many hours reading, Jules Verne, et cetera, all the classics from the time period. And he was an excellent student, with one exception. My nemesis too, spelling. And we all know of him, actually, he received his first telescope at age 8, and that definitely helped spur his love of science. Now, we all know of Edwin Hubble, the scientist. However, when he was a young man, he was actually not known for being a scientist. He was known for being a gifted athlete. Yes?
Can you hold it a little bit closer?
Okay, is that better?
Yeah.
Okay, thank you. So when he was young, he was noted more for his athletic skills than for his academics. He played basketball, boxing, football, track. And he really was a type A personality from childhood. When he went to college, he began studying astronomy and earned a BS in mathematics and astronomy from the University of Chicago. And he did that in 1910. However, he was also famous because he led the college basketball team to a Big Ten conference title in 1906. And I'm a Michigan alumni, and I remember when I did this, I was thinking, wait a minute, U of Chicago was in the Big Ten? Back then it was, no longer is. And he, after he finished his undergrad, his father was a professional in the insurance industry, and he really pushed him to become a lawyer. And Hubble, being the type A personality, became a Rhodes Scholar, went to Oxford, and earned a law degree. Everything this man did, he excelled at. After he finished his law degree, he became a teacher, and he taught Spanish and physics at a high school in New York in 1914. That only lasted about a year. His father passed away, and he was being a lawyer for his father's sake. Then he decided that he would, quote, chuck law for astronomy. And I knew that even if I were a second-rate or third-rate astronomer, it was astronomy that mattered. So he'd rather be a mediocre astronomer than an excellent lawyer. Now, of course, to be a professional astronomer, you need to get a PhD, basically. And he did go back to the University of Chicago in 1917, with his dissertation being photographic investigations of faint nebula. And that's going to be important as we go on here. Kind of a snapshot of his character. When he was a graduate student at Chicago, he was head of Snell Dormitory, and it had a reputation for having rough elements. And he said, it was not an issue, quote, they never gave me any trouble, partly perhaps I had been a Chicago man, and because I boxed. So I'm curious as to what kind of discipline he trying to do with the kids. Quick question, Eric. Is the mic being difficult?
A little bit difficult.
Okay.
It's the switch. It's the cheap mic.
All right. Yeah, 'cause I can hear echoes.
Try that one. Let's try this one.
Sure. Is this better?
We'll find out.
I can talk loudly and let the microphone pick me up ambiently if that's better.
Sounds good so far.
Okay. If it's not, give me a shout. I'll fix it. Now, what happened in 1917? World War I, exactly. Before he finished his doctorate, he had such an academic reputation that basically he secured a position at Mount Wilson before he did his thesis, his dissertation rather. And he finished his dissertation and he telegraphs Mount Wilson saying, quote, regret, cannot accept your invitation, am off to war, unquote. He volunteered into the US Army. And Mount Wilson said, Dr. Hubble, the moment you're done with your commission, come back and work for us. You have a job here. We will hold the position at Mount Wilson. He was that good. And actually, there's some question about, did he really see combat, which kind of surprised me, but he was wounded from a shell exploding and he got a concussion and an elbow injury. So he was brave and he did, fight for his country. And when he finished his stint, when the armistice was signed at the end of the war, he stayed on with the Army as a judge advocate for about a year. So he was actually doing law work for the Army. And then by 1919, he did return to civil life. He left the Army with the rank of major and immediately went to work at Mount Wilson in California. And that launched his professional career. And he stayed with Mount Wilson throughout his career. He did meet Grace Burke in 1924, and they were happily married. They had no children, though, but they had a really good life. They had party at their house. They had really neat guests like Aldous Huxley and other notables for the time. And it would have been great to have gone to one of his parties. Can you imagine the historical figures you'd meet in the 1920s and 30s?
I think it's your clicker that's actually creating interference.
Oh, is it? Let me turn it off. Did that do it? All right. So I'll run from here. When World War II broke out, he was in his mid-50s, and he immediately said, I want to enlist into the Army again. The US Army said, Dr. Hubble, your scientific work is way too important. Thank you very much, but please go do science. But he did contribute to the war effort. He actually did research in ballistics. And he earned a Medal of Merit in 1946 for his work in ballistic technology. So he did contribute to the war effort, even in his 50s. He also helped develop the Palomar telescope. At 200 inches, it was the world's largest telescope for decades. He had a hand behind that being designed and developed. And again, as I mentioned, him and Grace had no children, and they were married until he passed away in 1953 from a blood clot in his brain. And Grace lived much longer than he did. She died in 1980. So that was basically the character of Edwin Hubble. And like I said, I would love to meet him and have a conversation with him about his days in Snell Hall and how he kept discipline as a boxer. All right, that being said, I do want to take a little bit of a historical look at astronomy. And in astronomy, there's one truism. It's that the history of astronomy is a growing perception of how big the universe is and a shrinking prominence of human beings and Earth in that universe. And this is consistent and exponentially changing throughout the millennia of both amateur and professional astronomy. Let's go back to civilizations before the 4th century BC. And as far as the ancients were concerned, Earth was the universe. You had basically a flat Earth, and you had the dome, which had all the stars and planets and everything else above it. And if you think about it, this makes a lot of sense for somebody who may not have left an area of where they lived. They could have only walked a few miles away from their farm their whole life. And if your fastest transportation, animal or running, I could see why you perceive the universe as being this. And if you look at it, it makes Earth as the universe itself, the most important part of the universe. And then our journey begins. By the 4th century BC, the Greeks concluded that, Earth is not the whole universe. There's these wandering stars, which in Greek is the word planet, that go around us, and the stars go around us. And the Greeks said, yeah, the Earth is not actually the whole universe. It's smaller, so we're shrinking the universe. We're shrinking the Earth's presence, and we're growing the universe. But everything revolves around the Earth. Everything revolves around us. And by the 2nd century, the Greeks had figured out that the Earth was round. So that was an incredible breakthrough in cosmology. They even had scientific instruments. I forget the Greek name for that instrument on the left, but it was basically an astronomical calendar. Incredibly sophisticated, much more sophisticated than we ever thought you would have 2,000 years ago. Thank you. I couldn't remember the name of it, yeah. And the next step was the 16th century, after we came out of the Dark Ages. Polish astronomer Nicholas Copernicus, of course, determined that the solar system is heliocentric and that the sun is now the center of the universe. Earth is now bumped to the same place as the other planets. So growing universe, shrinking Earth. He also figured out that the Earth rotated around its axis. However, Copernicus thought that the sun was the center of the universe and the stars were going around it. So he got the solar system model basically correct, but his cosmology beyond that was still coming short. And he also thought the planets went in circular orbits, not elliptical. And of course, as we got better data, we figured out elliptical orbits, Keplerian laws, etc. And things really began accelerating at that point. By the 18th century, scientists like Thomas Wright and William Herschel concluded that stars were visible that the stars that were visible was the universe, and that the sun was just another star in the universe of stars. They thought that it was still the center in this vast field of stars, and didn't quite understand what a galaxy was, but they were on the right track. They finally, put the sun as in its proper place as another star. And again, the universe is getting bigger. Our presence is getting smaller. Everything changed with the Industrial Revolution, because the technology that emerged brought significant development in optics and telescope mounts. For the first time, you had machine technology that could create accurate equatorial mounts, which were first designed in the 1820s. And of course, optics to make much, much bigger telescopes. And the other big breakthrough was photography. In the 19th century, we developed practical photography, basically ending the multimillennial age of visual astronomy. And this is a photograph from 1888 of M31, the Andromeda Galaxy, shot with a 20-inch reflector. And that's a pretty good photograph for 130 plus years ago. Now, it was a 4-hour exposure, because of course, the graphic media cameras. But I got to say that is very impressive for 1888. And basically now you can do much more quantifiable science than visual astronomy using photography and other methods of photographic technology. Now, when we come to the turn of the 20th century, we're still trying to figure out our place in the universe. And there was a mindset that the Milky Way was it, kind of going back to Edwin Herschel or William Herschel's day, where everybody thought that the universe was the Milky Way. Now, astronomers with their new telescopes are beginning to see what they called spiral nebula. And we know them as galaxies, but they called them spiral nebula because they weren't quite sure what they were. There were huge debates. Were these inside of the Milky Way galaxy, or were they outside? With the Milky Way being the universe, they're just gas clouds or whatnot. Or what some said was, no, they are not inside of our galaxy. They are separate universes. That we have the Milky Way galaxy as a universe, and we have our other the spiral nebula as a separate universe. The problem was the debate couldn't be settled because we could not measure distances very accurately of astronomical objects. I mean, if you think back to the transit of Venus that happened back in 2012, in the 19th century, they were still trying to figure out how far away the Earth was from the sun, let alone trying to figure out how far away are these spooky nebula. And there was even great debates, like the famous one was Curtis versus Shapley, where they were trying to see, what are these nebula? And it was a pretty heated debate at the time, and nobody could get the perfect answer because we just did not have the tools to do it. So that was our greatest obstacle, was measuring distances. And this is where Hubble changed the universe. Now, I do want to go back into the history of distance measurement. So this will all come together. And the first method that astronomers employed was called parallax. And basically, what is parallax? When you're looking at an object in the distance and you put your thumb up, when you look at the thumb with your right eye, it's in one position. When you shift your eye, the thumb moves relative to the background objects. And they did that with the Earth. So they would measure the position of a close by star at one time of the year. And then when the Earth swung around to the other side of the sun, they could measure how much the star moved relative to the background stars. And it actually is a pretty good method. But there is one problem. It only works for stars that are relatively close. And science fiction fans know about doing the Kessel run in 12 parsecs, right? Yeah, a parsec is a distance measurement. It's not a time measurement, but if you watch the movie Solo, you'll figure out that it actually makes sense. But anyway, so big science fiction fan. A parsec is 3.26 light years away. And at that distance, a star will displace 1 arc second if the Earth moves 1 astronomical unit in space. And 1 astronomical unit is the distance between the sun and the Earth. And 1 arc second is a very small piece of sky. I have a 14-inch Dobsonian telescope, and my resolution is 1/3 of an arc second. The nearest star is Proxima Centauri at about 4 light years away. My telescope could barely measure the parallax shift of Proxima Centauri, let alone any further stars. But if you have a big enough telescope, you can make this work, over a few dozen light years or more, if you have a good enough instrument to pull it off. And that gave us our first inkling into having a yardstick. The next breakthrough was the Cepheid variable breakthrough. And we all know that some stars change in brightness. So you have variable stars, and some of those variable stars have a very steady pattern of changing brightness. Some stars are irregular. And if any of you guys are very star observers, you all know about this. The thing with Cepheid variables is, unlike Betelgeuse or other stars, it has a very precise and very predictable pattern of changing brightness. So with a Cepheid variable, like this one per se, you could have a change of brightness going over 7, 8, 9 days, and it'll happen consistently over and over again, like clockwork. And the other breakthrough of Cepheids was that the absolute magnitude, and absolute magnitude is how bright a star is regardless of distance. And at 10 parsecs away, you can say this star is such magnitude, another star is a different magnitude, and this, you get an absolute brightness for it. The absolute brightness of a Cepheid variable depends on its cycle time. And you can see where this is going. Henrietta Swan Leavitt, who was called a calculator, where she would run numbers for astronomers and also an astronomer herself, discovered this. And she is an unsung hero in astronomy. I think a lot more people need to know about her, because her breakthrough was part of what made Hubble have his revolution. Because what she discovered is, if you take a Cepheid variable and if you plot its cycle time, let's say it has this 50-day cycle time, and let's say you have this type 3 Cepheid, you know that any type 3 Cepheid that has a 50-day cycle time will have a set absolute magnitude, in this case of about -4.1. And here's how we'd use it as a yardstick. Imagine you have a 60-watt light bulb. And let's say you buy a bunch of 60-watt light bulbs from the same vendor, and they're all the same manufacturer, same lot number. So no matter where you have the 60-watt light bulb, it's going to have the exact same brightness. So you could have a 60-watt light bulb, its brightness, and let's say its distance. And if it's a star, it through parallax. So its distance away from you, how bright it is in an absolute sense. And let's say you can see star A. Let's say you have another Cepheid variable with the same cycle time, just to keep things consistent. So its brightness, but it's a lot dimmer. Since both of these stars are the same brightness, and if you use a different yardstick like parallax to know where star A is, based on the difference in brightness, you can figure out exactly how far away star B is. And this was huge, because for the first time, we could measure distances in our Milky Way and outside of our Milky Way using Cepheid variables. Henrietta did one of the most incredible discoveries in astrophysics about 100-odd years ago. Sky and Telescope had a great article about her, I think in 2020. If you ever want to pull that issue, it's really good. So I'm setting up what Hubble did here with a little more background. Another great debate in the 1920s, and if you were alive in the 1920s as a scientist, that was the golden age of science. Every single field was exploding in knowledge. And there was a lot of arguments, of course. In the 1920s, another question was, did the universe have a beginning? And steady state was a common theory, meaning that the universe never happened, it always existed. And even Albert Einstein bought into this in the beginning of his career. In 1927, there was a scientist and Catholic priest named Monsignor George Lemaitre. He was from Belgium, and he had a radical idea that the universe began from a single point, a primeval atom, and expanded into existence spontaneously. He was really pilloried for this idea. A lot of scientists are saying, no, there cannot be a beginning. There has to be a constant universe from time immemorial. And again, it was a big debate. His idea was essentially the beginning of the Big Bang Theory. It's a common misconception that Hubble developed the Big Bang Theory. He didn't. Monsignor Lemaitre did. But they did work, but their work did correlate together. And again, as I mentioned, the validity of his theory was widely debated. So it was summarized late 1920s. So we had spiral nebula. They were known. We weren't quite sure what they were. We had the first long distance measurement yardstick, which was the Cepheid variables. Practical telescopes and photography gear now existed. The modern age of instruments and scientific usage of them was born. And the idea of the universe having a beginning is proposed scientifically. And this is the perfect cosmological storm that Hubble was in the middle of. In 1923 at Mount Wilson, he was taking photographs of the Andromeda Galaxy. And this, again, was cutting edge technology. And what he was noticing were novas in the galaxy. And he was able to resolve individual stars for the first time in that galaxy too. And he was looking at these novas. He categorized 3 novas. And a nova is when a star basically, it doesn't quite explode, but it sheds layers of gas. And that's what's going to happen to our sun in about 4 billion years. But he discovered he made a mistake. One of the nova was actually a Cepheid. And that was the big light bulb moment. Because all of a sudden he said, we have a Cepheid in Andromeda. And when he ran the numbers, he said, this is not in our galaxy. This is in fact another universe. And going back to my original point, with that single discovery, he displaced the Earth's position in the universe more significantly than any other astronomical discovery for thousands of years. All of a sudden, the Earth is just one planet around one star in one galaxy among many other galaxies. And the universe the size of the perceived universe just exploded at this point. So that was his first major discovery. And this will lead up to the next major discovery, and that's spectroscopy. We've all played with these as kids. You can take sunlight and you can break it up into a spectrum. And if you look at a spectrum, you can see what are called, you have absorption lines. And if you have elements, they'll cause absorption lines in the spectrum. So you could take a spectrum of a star and find helium, hydrogen, different states of different elements, et cetera. And this had been known since the 17th century. And by the early 20th century, with the advent of practical photography, astronomers began taking spectra of stars and galaxies. And along those lines, I want to talk about Doppler shift. So I'll introduce 3 characters here. We've got Jenny, Billy, and I've got cats at home. I love cats. Nicholas Copernicus, who was Hubble's cat. So we'll introduce him too. And let's say we have an ambulance going from Jenny to Billy. And basically what happens is the sound waves, as they approach Billy, get compressed. As they recede from Jenny, they get stretched. And the pitch of the ambulance siren or the ambulance wind noise changes. So of course, Jenny will hear a low-pitched siren because the waves are stretched. Billy will hear a high-pitched siren. And of course, Nicholas will hear the Doppler shift we're all familiar with, as the ambulance drives by. And light does the exact same thing. So this is M31, the Whirlpool galaxy, and we'll have it traveling left to right. Billy will be millions of light years in front of it. Jenny will be millions of light years behind it. And if they were to take a spectrograph, Billy would see the galaxy as blue shifted or bluer because the light waves are being compressed as it approaches him. Jenny would see the galaxy shifted towards the red because it's receding and the light waves are stretched. Nicholas Copernicus, the cat, or Hubble's cat, his life is too short to notice any change, so he would just see the galaxy looking regular. But if he were able to live billions of years, he would see the galaxy change from blue to redshifted. And this is actually a photograph of a spectroscopic image that Hubble took at Mount Wilson. So what he was doing is he was looking at galaxy spectrum through a spectrograph, and you can see emission lines. If you look to the left here, you can see the HK emission line and other faint emission lines. And he was trying to see, were these galaxies redshifted? And just to go over, if you have a galaxy spectrum here, it goes from blue down to orange. You've got an HK emission line. And if there's no motion, that's what it looks like. If the galaxy is moving away from us, the entire spectrum, including the emission lines, are shifted towards the red. If the galaxy is moving very quickly away from us, the whole spectrum may get shifted into the infrared range, which we as human beings cannot see. And I can talk about the James Webb Telescope and why it's infrared. And this is one of the reasons. Because James Webb, unlike our eyes, can see galaxies that are moving so fast that their entire spectrum is shifted beyond our visual range. Now, let's go back to steady state versus the primeval atom, or the Big Bang Theory. If we had a universe that was steady state, and if Nicholas was there on Earth looking up with his telescopes, what he would notice is there'd be all different shifts in the galaxies around him. Because the universe is steady state, everything's kind of just doing its own thing, moving around. So you'd have some redshifted galaxies, some blue shifted galaxies, and some galaxies with no redshift at all or blue shift at all. So that's what a steady state universe should look like. If we had a universe that was shrinking and Nicholas the cat looked up around him, he would see all of the galaxies blue shifted because they'd be racing towards us because the universe is shrinking. And if the universe were expanding, he would see almost all of the galaxies being shifted or moving away from us because they're all part of the expanding universe going away from Earth. And when Hubble began recording spectrums, he consistently found that almost every single galaxy he looked at was redshifted. No matter where he looked, redshift, redshift, redshift. And the fainter the galaxy was, the bigger the redshift. Now, there are some exceptions. Andromeda actually has a slight blue shift because Andromeda is approaching the Milky Way, but that's a local phenomenon due to the attraction of the two galaxies together from gravity. But when you get beyond Andromeda, everything's redshifted. And this proved that the universe was in fact expanding. And his spectrum data confirmed that Monsignor-Lemaitre was right. The universe did begin as a single point. Now, this didn't happen instantly. This took years of research and, basically redoing other people's work, et cetera, to make sure that it all fell together. So it's not like in 1929, oh, Big Bang Theory is proven, we're good to go. It took a lot of time. And Hubble, of course, had to sharpen his pencil and make sure he got things right. His initial distance estimates using some of these methods were actually incorrect. He had to refine them over time because he got better at it. He at first thought the Andromeda galaxy was 900,000 light years away. We know it's about 2.2 million. But that's science. You get better at using your tools. But needless to say, he basically further pushed our perceived universe as being vaster than we ever imagined. Because now he's seeing thousands and thousands and thousands of galaxies that are all racing away from us. And Albert Einstein even admitted he was incorrect in his original perception of the universe. And being a scientist, that's what you do. You get better data and you say, well, okay, I was wrong. Toss the old theory. Now, this radical change basically showed we have an expanding universe. And if you studied astronomy in the past, you heard of Hubble's law. In the last few years, they actually changed it now to the Hubble-Lemaitre law because they want to give credit to Lemaitre for this. But what Hubble discovered is that a galaxy's distance is proportional to its velocity moving away from us. If you ever study science or engineering, you discover that very few things are linear in the natural world. Almost all scientific phenomena are exponential, quadratic, logarithmic, etc. You almost never see stuff that's linear. I don't like to show equations in my presentation, but I can't resist with this one. if you have the V is the relative velocity of a galaxy moving away from us. H is a constant that Hubble developed. D is the distance. The bigger the redshift, the faster the galaxy moves. The faster the galaxy moves, the bigger the redshift. Sorry, I messed it up. The faster the galaxy moves, the further away it is from us proportionally. So if you have a galaxy moving at twice the velocity of another galaxy away from us, that other galaxy is twice the distance. It's that simple of an equation. And this is his data where you have, linear distance and linear speed. Again, pretty remarkable for the natural world. Now, I'll talk about dark matter in a little bit, and this isn't quite right, but that's a more recent discovery. But wait, there's more with Edwin Hubble. So, he was an accomplished lawyer, accomplished athlete, led a championship team. He was a soldier. He also accomplished research for the military, helped build the Palomar telescope. And he also developed a nomenclature for galaxies. He also developed the yardstick, of course, to measure intergalactic distances. And he came up with a Hubble classification system for galaxies. So, where we have barred spirals, we have conventional spirals, we have elliptical galaxies, and that was through his research. And he also finally answered the question, what is a spiral nebula? It was perplexing astronomers up until the beginning of the 20th century. I think if you were an astronomer or astrophysicist and you did any one of these things, you'd be famous in the annals of scientific history. And he did multiple game-changing things. And with that, the Earth's place in the universe is made even smaller, more fragile and precious, and the universe vaster. On a philosophical note, I know some scientists say that, the Earth is insignificant. We are a speck of dust in the cosmos and we have no meaning. Personally, I take the opposite. I think the fact that we are so small and fragile makes us special. And it should give us a consciousness of knowing that the Earth is our home, as small and, obscure as it is, and we should take care of it to make sure. So far, there's no other place like Earth, even in all the exoplanets we're looking at. And even if we found another Earth, we're not going to be able to get there, at least not for a very long time. So this makes us feel like we have a very precious Earth to live on. Now, steady state did not die. Anybody watch Cosmos back in the early 80s? Carl Sagan? Yeah, I was in middle school, loved it. Carl Sagan talked about this idea where you have what's called the oscillatory universe. And you have a Big Bang. The universe expands from the momentum of the Big Bang. And eventually you reach an equilibrium where the universe expands to a point where it catches up and begins rushing everything back together. And then, of course, the universe begins to contract. And it has called the Big Crunch. And then once it hits the Big Crunch, it does a Big Bang again. And this was a going theory in cosmology about 40 odd years ago. And it kind of makes sense. If your understanding of the universe is just what we see, and you run the numbers, okay, it was a plausible idea. And from a science fiction standpoint, it kind of brings up an interesting question. If we do have an oscillatory universe, does the universe repeat itself exactly as before in every cycle? Are we destined to live these lives over and over again? Or do we have a universe with completely different laws of physics that come up? And it was kind of a new steady state. And of course, it begs the question, how did it all begin? But the oscillatory universe didn't survive as far as the theory, because Hubble's namesake, the Hubble telescope, made us realize the universe is even vaster than even Edwin Hubble dreamed about. It showed that we a number of galaxies, and there was one famous photograph that we've probably all seen. That was the Hubble Deep Field, shot in the 90s. There were some scientists that were saying, okay, we want to take a picture of the sky, and they take a blank area of the sky. this area right here encompassed probably about the same angular size as taking a soda straw and putting it up to the sky. And they did a multi-day exposure on this, and they're not going to see anything, just a blank bit of sky. This photograph is not photographs of stars. There are some local stars scattered through here, but almost every single point of light there is a galaxy. There are billions to trillions of galaxies, not hundreds of thousands, not millions, but billions and billions, if not trillions of galaxies in our universe. If you get a chance, all the Hubble stuff is public domain, and NASA downloads a lot of these or all of these raw files on the internet. Pull up this photograph in raw form and just look at all those little points. Those are all galaxies. And this further shrunk how big the Earth is in the universe, how tiny the Earth is, how tiny our presence is, and how vast the universe is compared to it. Exponential change in terms of our perception going on from the ancients all the way up to now, and the curve just goes straight up. Now, there's a common myth that the James Webb Telescope destroyed the Big Bang Theory. If you read that headline, don't bother reading the article because it's not true. All right. And this is actually quite an annoying thing that people have a misperception of. And I blame journalists for having the headline, James Webb Space Telescope disproves the Big Bang Theory. Do you remember how I talked about the spectrum? And that distant galaxies are redshifted into the infrared? The Hubble Space Telescope only went to a very small part of the infrared spectrum. The galaxies that are very far away are very, very old because that light takes 13 billion years to reach us. So when we're looking back at these faint galaxies moving so far that they shift into the infrared, those are some of the early galaxies that formed in the universe. And until we had instruments like James Webb, that time period, which was a few 100 million years after the Big Bang, we didn't understand it very well. We had some ideas on star formation, but when James Webb began looking at that time period in our universe's existence, it discovered stars and galaxies formed a lot earlier than the Big Bang. So what James Webb rewrote wasn't the Big Bang Theory. It rewrote the sliver of time in the formation of the universe that we did not know much about. So that's what it did. So the demise of the Big Bang has been greatly exaggerated. Now, what will happen to the universe? And what's going to happen is what's called heat death. At least that's the going theory now. The Hubble Space Telescope gave us an understanding of the vastness of the universe to the point where we discovered that galaxies are not consistently moving at the same speed away from us. The speeds the galaxies are moving away from us is increasing. And at first, astrophysicists said, what the heck is going on? Well, this led to the discoveries of dark matter and dark energy. I'm not an astrophysicist, so I can't really go into much detail about this. And this is way above my intelligence here, but apparently dark energy is what's accelerating the expansion of the universe. And we can't see it, but what it's causing is the loss of gravity in that oscillatory universe. Gravity loses the battle of trying to pull the universe back together. And what's going to happen over trillions of years, timescales that are vaster than we can even begin to imagine, the universe will not crunch. It will forever expand to the point where stars are burned out. Energy and matter are scattered to the point where the entire universe consists of a cold, near vacuum state, occasionally interrupted by a subatomic particle whizzing by. And some physicists think that this expansion will be so vast that it's going to actually start ripping apart the actual fabric of space-time. And this is getting into like Doctor Who episodes here, I think. But that makes the universe even vaster than we even thought in the 20th century. To the point where not only is our physical space in the universe insignificant, but think about this. If our universe is going to live trillions of years, if not into infinite time, our time period in that universe is extremely tiny. So not only has our presence in geometric terms been shrunk to near nothing, our time in this universe has been shrunk to near nothing, which makes our existence even more special and precious. So on this tombstone, what I have are three equations, of course. I have the entropy equation, because if you study thermodynamics, you know that everything goes from order to disorder, and that's what's happening to our universe. You cannot reverse entropy. You know, it's kind of like you can drive a car down a road using gasoline, but you can't take the exhaust and stuff it back into the gas tank and recreate gasoline. Of course, I have the Hubble-Lemaitre law. And then at the end, I have the heat transfer equation, meaning that heat death is the ultimate end of our universe and the ultimate vastness that's personally utterly incomprehensible. So, being said, before I go into questions, I do have a quiz.
Uh-oh.
As a cat person, what was the name of Hubble's cat? Nicholas Copernicus, yes. That was his cat's name. If you ever read about him as a person, it's an interesting read. Their marriage sounded awesome. His wife Grace wrote diaries about their life together, and this is great. When Edwin worked in the study at his big desk, Nicholas solemnly sprawled over as many pages as he could cover, because he would have journals and papers. He is helping me, E explained. When he sat on E's lap, he purred differently, a slow, lion-like purr. Is that your cat purring? I would ask. E would look up from his book, smile, and nod his head. And Nicholas outlived Hubble by about 9 years. And Hubble passed away in 1953. You know, she wrote that he would be waiting at his window for him to come home. And unfortunately, he never did. And the cat was a frisky character because in their lives together, they had lots of VIPs coming over to their house. And the cat would kind of judge each person. Have you ever read Brave New World? Aldous Huxley was friends with the Hubbles. Nicholas hated Huxley. He actually, like, you know, would try to scratch him and whatnot. And Huxley's like, what the heck? So yeah, you could, there should be like a children's book or something written about Hubble's cat, because I'm sure that cat would tell lots of good stories. But yeah, so interesting stuff. And like I said, a very complex man, and also a very type A man. No matter what he put his mind to it, he excelled. And every one of those topics, if any human being did, you would consider a great person. And he excelled in so many things and did so many groundbreaking discoveries. An astrophysicist would love to have just one of those discoveries under their belt, and he had multiple. So that being said, do we have any questions?
There was a question that came up in a previous meeting that we had on Tuesday.
Oh,
We get together, we sort of talk about what's going to be spoken about ahead of time. The absorption lines on the spectrum, do they get redshifted so far that you can't tell the distance anymore because it's way into the infrared? Or do the absorption lines actually repeat?
the absorption lines actually travel with the spectrum.
Okay.
So it's they're not independent of the spectrum, but they actually travel with it. And as far as the infrared goes, the only limitation is our eyes. And that's why, like I said, James Webb has such a depth into infrared. It's because it can see where no other telescope has seen to that level of resolution. Now, other telescopes did look in that part of the infrared spectrum, but the James Webb has I should know the size of the mirror, but has a vast mirror that no other telescope could resolve to or see objects that dim to. Because like IRAS also went in the infrared, and what was it, the Spitzer went in the infrared, but their mirrors were tiny compared to James Webb. Yes.
So I'm assuming the spectrum lines or Fraunhofer lines would end up in the radio wave spectrum as well. It can't be seen.
Other direction. There's a fear of blue shifting because the radio waves are longer wavelengths of light. So you have to have the galaxy flying towards you at a very high speed to pull that off. Oh, no, I'm sorry. You are correct. You are correct. Goodness, you are correct. You're, yes. Yeah, I'm sorry. You are correct.
Radio wave.
Yes, but judging from what I've learned, that if we're in infrared and we're 200 to 400 million years into the Big Bang, I think we'd run out of time to shift them that far.
The original wavelength was in towards the infrared. Let's say it's hydrogen alpha.
Right.
wave, and you get that far out, it would be closer to radio wave than infrared.
That's a huge shift though, yeah. Yeah, because right now, well, but see, here's the thing though, the James Webb is in mid-infrared. It actually does not go into far infrared. At mid-infrared, it's gone back 300 million years after the Big Bang. I think the problem is if you started getting the radio waves, you'd be so close to the singularity that stars haven't formed yet. That's probably why the microwave background, I'm not an astrophysicist, so somebody correct me if I'm wrong, but the microwave background noise is actually from the beginnings of the Big Bang, and that might be where you're shifted that far back. I don't know if there's a physicist here, that's a question I would ask. Wavelength was too, right. So we're assuming that the galaxies and the stars that initially formed were invisible light. And with James Webb, we're in the mid-infrared. If we go further back in time, there's no stars. So, but I guess if you had a hypothetical star, maybe you'd be back into radius. I don't know. I'd have to run the numbers. Yeah.
Which telescope is that?
That I believe is Mount Wilson, because that's where he's.
60-inch.
It's about 48 inch.
Yeah. But yeah, he spent his whole career at Mount Wilson, basically, with the exception of going off and building. But yeah.
Is the curvage poker stroke that he used to make the discovery, is it still in use?
Yeah, it's open to the public, I believe, too. Yeah. I do want to go see it because I would love to go see an awesome piece of early 20th century craftsmanship. I think talking about the Industrial Revolution, if you ever get a chance to look at telescopes made in the 19th century for professionals, they are works of art. I mean, brass and they didn't have electronic clock drives, so they had these glorious mechanical clock drives to move the telescope. And as a mechanical engineer, I just envy those guys because what they pulled off using non-computers, basic drafting and slide rules is incredible. And I really tip my hat to those guys. I'm spoiled using computer-aided design. Yes.
You were wondering about the Webb mirror is 21 feet 4 inches.
Thank you.
Which is just a little bit larger than my finder's scope.
Well, what's interesting is that that's well over 200 inches. So if you think about it, James Webb is bigger than Palomar. That kind of puts in perspective what kind of optical potential the telescope has. I mean, it's bigger than Palomar, which was the largest land-based telescope for decades, from 1940 to I think 1980-ish or so. Yeah, I can't remember the exact dates. Any questions online? Okay. Anybody else have questions?
Do you know, so getting back to the CP variables for a moment. He had to have been able to measure the luminosity
Right,
to be able to get the distance.
right.
Well, back then, what kind of tool or equipment were they using to measure the luminosity? You know?
Did anybody know that question, what they were using? My thinking would be photographs, but I'm not sure, actually. That's a good question. That would probably be around that time, I would think. Yeah. 'Cause Tesla was playing around with that kind of stuff back at the turn of the 20th century. Yes.
Well, back in the late 1800s, early 1900s, you had the calculators. Their job was to figure out all the magnitudes and everything like that.
Yep.
Was their job. And so they had lists and lists of all that. And wave went down to South America, down in there, and did from the photographs down there, they did the measuring. So they had loads of information and then she could put that all together when
Yep.
she came up with her.
And that was her big breakthrough. And it was a shame because she was a brilliant astronomer, but because she was a woman, oh, honey, go do those calculations.
Right, yeah. But there, again, brilliant of that, there's a book out about the Harvard astronomer, lady astronomer.
Class university.
In Math University.
Yeah,
And that's a fantastic read.
yep. Another famous female astronomer was Mariah Mitchell.
Yeah.
That's another, because I do outreach with kids and I go, encouraging kids to go into STEM. I go, if anybody's interested in heroes, here's some heroes, Mariah Mitchell, Henrietta, of course, Hubble, Patrick, et cetera. Any other questions?
Thank you, Michael.
Thank you. I hope the sound worked out. So.
You can leave the mic on for Tim.
So thought-provoking, isn't it? Michael showed us how our original knowledge of our Earth as being the only thing that there was in the universe to the ancient Greeks. And now our view of where we are in the universe in time is just so much different. So I wrote a note as he was talking and that how small and insignificant and obscure. And I crossed out the words insignificant and obscure because and then I realized as you spoke that our Earth is small, precious, and rare. And our place in it, I think we have greater appreciation now, knowing the history now and the great work that Edwin Hubble did. The other thing that occurred to me was it wasn't just his work. He was building on the shoulders of giants, as we say, right? Going all the way back to the ancient Greeks, to Aristotle and Ptolemy, building on the works of Copernicus and Tycho Brahe and Kepler, the German refugee Einstein, the female before the feminist revolution, Henrietta Swan, Annie Jump Cannon was categorizing stars. I mean, just all these great minds working their pieces of the science to all add up together. Then I come to think of those were individuals all along the way over centuries. Now just think of how many more great minds and scientists all over the world that we have working in NASA, the European Space Agency, the Japanese Space Agency, all of them. So how much more advancement can we expect to learn in the next few years in our generation, right? So excellent presentation, really. Thank you so much, Michael.
Thank you for the invite.
Yes, thank you. Okay, hey, Bill, roll on up here. You've got an announcement to make.
I do. Do I?
Yes, yes, you do.
Just wanted to, and I don't know if you need this or not.
What announcements are we doing? These ones?
Yeah, he's doing July 15th.
I'm doing July 15th, the high altitude star party. And if you could put up the dark sky clock.
So you want this one?
Dark sky clock
Oh,
right here on the right.
let me drag it over here.
Okay.
People can see it.
We can slow down on the program, Eric, if you need to catch up.
I do.
I think we're doing just fine.
Hiding right here.
I see it kind of. I see a couple of bars there. There we go. Okay, so I don't know if any of you have ever used the clear sky chart. And here we are on Friday the 14th, tomorrow night. And if you go over to 2300 hours, So at midnight, we're going to have no cloud cover. Transparency is going to look pretty good. The only thing that is really a problem here is seen. And you could go over to Saturday night and sort of see the same thing, although we may have some wispy clouds coming in. And then Saturday night, seeing is going to degrade a little bit, and the darkness is going to be about the same. But everything else looks okay. Might have some smoke, a little bit of wind, it looks like. Humidity is fine. Temperature is going to be quite warm. So if you're going up there, make sure that you hydrate, please. And we don't want any accidents for sure. If you could go to the map, please. Our primary location is way gone away.
I'm sorry.
That's okay. Please stand by.
Can you move out of my way though?
Yeah. I'm eclipsing the thing. Eric just called me fat. There you go. Okay, so this is a map of to Peddler Hill, and Peddler Hill is in there. You could right here where the scenic viewpoint is. So if you're going up 88, and you get to the Peddler Hill scenic viewpoint, you have gone too far. Where you want to go is right here, Bear River Road. And it'll be a big sign right here that will say Bear River Reservoir, and it's pointing the other way. You want to make a left onto 8N31, it's Forest Road, and just follow it. Follow it up, and it's right there. You take a right-hand turn at that flat spot, and what that is an old ski resort from the 30s. And that's all been torn down and stuff, but that's our primary. I'm going to try to get up there Friday night and reserve our place there in the regular place, and have Saturday night. There is a secondary place that is up the road quite a bit, and that's called Iron Mountain, and that is not a federal land, that is private land. And that is an ski resort that closed down and was actually involved in the Caldor fire. Everything was burnt down there. And it's past the Peddler Hill Maintenance Station. It is about, there it is right there. Mormon Immigrant Gap is where you make a left-hand turn. And I will communicate as much as possible via text and try to get an email out to the group, but I will rely on the group to communicate to others if we have to punt. It is the potluck. Don't worry about it too much. Just bring something to share if you would. Bag of chips works. Yeah, I'm not planning much, that's for sure. I'll bring up a couple of tables, but if you got a small table that you could bring, definitely bring your chairs. And if you bring something up, plan to pack it out. We want to pack everything out. We've had situations where the last person there got stuck and was taking down 3 big old garbage bags of stuff. So if you bring it in, pack it out. That's about all I have at this point. And yeah.
What's the road condition?
Oh yeah, I wanted to talk about that. Thanks for saying. Yeah, that Forest Road. I was up there a month and a half ago, and there was 3 feet of snow, and it has melted, and it shows some sign of creek damage, but it's okay. I wouldn't take a smart car up there. but my truck made it no problem, and an RV, a medium-sized RV, made it just fine. I met him up there last weekend. I drove up.
So to the event.
Yes, yeah, absolutely. Same thing with Iron Mountain. There was 6 feet of snow there when I was there a month and a half ago, and that's all gone as of last Thursday. So unless it snowed, but it's there. High fire danger up there. It is R3, R4 steady, and I wouldn't doubt if it goes to an R5. So that is, don't even exhale. So if you're a smoker or something, I would plan on smoking in your car. And are there any questions about the high altitude star party?
So you'll get up on Friday night.
Yeah,
We're all gonna be on our Yahoo chat
right.
and,
Or I will be texting.
okay,
I'm going to do both because both can be unreliable.
right.
Yeah,
I've gotten cell signal.
absolutely. Absolutely. And it's halfway dependable, but it's at other times it's just not dependable at all. It's insane. As far as big scopes go, nope. And I know there's a 24 not going up, and my 22 is having the mirror reground. So, and so I don't know what the big scopes are situation is, but there's going to be plenty of 12s and 14s and things like that. And we're going to see some stuff regardless.
Excellent. Look forward to seeing you up there, Bill. All right. And on the announcement slide, M22. We're going to see that Saturday night in Sagittarius. You don't see that every night of the year. Coming up in August, our meeting on the 10th, Eric's got this presentation, arranged the speaker on pulsars and RATs.
He's gonna be over Zoom from West Virginia,
Okay.
so it's gonna be a bit late for him.
I'm pretty sure I know what a pulsar is. I'm not sure I know what a RAT. Anybody know what an RAT is? I had to look it up.
It's a type of pulsar, I believe, but it stands for rotating radio transient.
Of course.
Yeah.
Of course it does. So we're going to learn about that in August. Okay, perfect. Are you thinking about doing a movie night before and we can prep on the subject?
We can try to.
Yeah, okay, good. Then we have on the 12th, our Highway 4-star party, and Eric, why don't you go ahead and make a little announcement about our alternative to this plan?
Okay. I actually have a mic here, but. So there's a new, well, let me bring up a map. You should have told me.
It's work to, I have to develop a new viewing time for us.
That's a job.
I don't. We've got 2 sites. I'm just saying, not having Highway 4 here. High altitude, we spend another kind of low altitude site, like they're already frozen. Just to the north of that body of water there is already.
Okay, so I hope that people that on Zoom land can see this. I don't know if I shared it properly. So this is called the Wildermuth House Trail. It's at this Campo Seco equestrian trailhead near Valley Springs. It's about 30,000 square feet. It's a big pad. You can kind of make out the cars there. These are like cars with horse trailers to take them out on the trail. And so we have access to this site at night on both third quarter moon and new moon. It's controlled by East Bay Mud, and there's a gate roughly around this position here that they have put a combination lock on there for us. So we can use this site as an alternative to Highway 4. People have been to Highway 4. It's a nice location. It's right off Highway 4 near just before Copperopolis. It dead ends, but it's hard to get cars turned around on there. It's a very narrow road. And so I think this site is a little bit better in that regard, is it has this big pad that we can drive around on and turn around. I was out here a few weeks ago. I wanted to get a sense of, you know, since it is a horse trail, what the manure situation is. There was some, but it was actually a lot cleaner than I thought it would be. Yeah. It's not any worse than the goose crap at Oak Grove, yeah. There were a lot of mosquitoes, so if we do go up there, make sure to bring bug spray. I think I got bit within 30 seconds. But the only real trees that are bothersome are right here. But I think if you head back and set up near the back side of the pad here, you could look over these pretty easily.
Is north up on this?
Yeah.
So that's south.
Yeah, so it's actually south is a little bit more this way, I think, actually. So like right between here. And there's a little bit of a hill here as well, but you can look over it. But it was a pretty nice site, actually. There are cars that you can see on this road a little bit, but they're a few hundred feet away. I don't really think there'll be a problem at night. You're probably not going to get a lot of cars on this road anyways. It's a pretty obscure location away from the normal city lights. But yeah, it's an alternative that I think we can check out.
What's the nearest town?
You can zoom out till you can see Valley Springs there.
Oh yeah, Valley Springs is
Oh, okay. I don't know.
where is it? It's down here, there, yeah. So you can take Highway 12 out that way.
Right.
Or 26. This is 26 here. I mean, more from the south.
I could definitely stop and get a cold soda or sandwich down there in Valley Springs a lot easier than you could at the at the Highway 4 site.
Yeah. So while we're using the site too, they want us to keep the gate locked while we're using it to keep people from entering the site while we're there at night.
Nice, okay.
Yeah. What was there?
What's the skyline? I mean, light pollution.
Oh, it's still probably like a Bortle 6.
Yeah, with Valley Springs just to the south of you. You're gonna see sunshine.
Yeah, we've been looking for alternate to Highway 4 for different reasons, and this may pan out. So I'm really looking forward to exploring it and trying it a few times. So. Okay, and then we've got another high altitude, August 18th. Hopefully that we've got good weather and no wildfires. There was a second slide there, Eric. Did anybody see the June 24th Stockton record? We made page 3. And sorry, Doug, I didn't blow it up, but Doug is quoted here in his interview, doing a great job of promoting the club and our work is pushing the Astronomy in the Park events. In fact, I wanted to ask all the folks that have volunteered out at Oak Grove Park this year at Astronomy in the Park events to please stand up. Recognize these volunteers who've been out there. Stand up.
Those two over there.
Yeah. 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 I think if our club is known in the community for anything, it's our work at Astronomy in the Park. Over the years, Doug, how many years have been going out there?
2009.
Okay, so good 13 years or so now, 14. We had a great crowd. I think we counted 75 or 100 folks out last time. So coming up just in a couple of weeks, the 22nd, Astronomy in the Park. See you out there again on August 19th. So, and we learned that after the event, that a hamburger at Nations is the best tasting hamburger you've ever had. And they're open till 1 a.m. So, yeah.
Cheesecake because it's addictive.
Addicted. Okay. We don't want to fall prey to the addictions, right? Well, with that, I think that concludes our business. Unless somebody tells me you've got something to comment on or bring up while we're still in session here.
So, since everybody's here still, I got can you guys hear me? Okay. We have a request for a star party out at Indian Grinding Rocks. She thought that August 18th would work for her. So put that on your calendars and maybe we can run up there on Friday, because Saturday is the 19th. We'll be busy.
That's on Friday night, the 18th.
Yeah, I figured that we could do it on Saturday, so I figured Friday would be the only one that we can do.
What kind of group is that? What kind of group
She
is?
doesn't know. It's just the ranger at the state.
Oh, huh.
They've got campgrounds there. They got all
Yeah.
sorts of stuff.
So,
In the big meadow there?
yeah, we're gonna need at least 3 or 4 scopes up there.
I could probably get coming. Pine Grove, yes.
Good.
Yeah. Okay, good. August 18th. Is there a Nation's hamburger nearby?
Oh,
There ain't.
There's nothing there. Grind your own. All right.
Yeah.
bring your acorns.
Get to work.
Yeah. Okay, again, I ask for any other announcements or comments from anybody before we adjourn. Let's take this opportunity to thank our speaker one more time. Thank you, Michael. Excellent. And with that, not hearing any other business, I'll declare us adjourned here. Thank you all. Thank you all on Zoom.